for large sample sizes may be statistically significant, even though it may have no practical significance. It may have no practical significance. The difference may not be large enough to cause concern or be considered important. That's all it means. So let's look at two examples. Let's start. According to the American Community Survey, the mean travel time to work in Collin County, Texas is 27. So the mean is 27.6 minutes. The Department of Transportation reprogrammed all the traffic lights in the Collin County in an attempt to reduce the travel time. To determine whether there is evidence that the travel time has decreased, so I can immediately state the null hypothesis as being mu equals 27.6 has decreased. What will you write as the alternative?
Less than 27.
Excellent. So it's a left-tail test, okay? As a result of reprogramming, the Department of Transportation obtains a random sample, large sample, 2,500 commuters, records their travel time to work, and finds a sample mean of 27.3 minutes. With the standard deviation of the sample, 8.5 minutes. Does this result suggest that travel time has decreased at alpha 0.05 level of significance? And the question is the result. Let's see what we get. So first of all, independence, yes. Independence, indeed. 2,500 is definitely less than 0.05 of the total number of commuters in Texas County, Collin County, Texas. Okay, the sample size is large enough, so I don't have to worry about. So first of all, the sample is a simple random sample. It's large enough for normality, and they're independent observations. So the conditions are fulfilled. So for that reason, I will determine the T statistic, which we don't have to. Oh, I'm sorry, Sean. I have to go back to the previous problem to show it in StatCrunch. I didn't forget. Sorry. So X bar, 27.3 minus 27.6 divided by 8.5 divided by the square root of 2,500. And degrees of freedom, 2,499. 2,500 minus 1. Okay. So with the graphing calculator and then with StatCrunch. We go to second in distributions. No, test. The t-test, number 2. And this time I'm going to use statistics, not the data. Mu 0, 27.6. X bar, 27.3. Standard deviation 8.5, sample size 2,500, and as you already told me, it's a left tail test, and I want to directly draw. Maybe I should change this into some other color. Maybe it's better. Okay, and I want to draw. Okay. So I got the test statistic to be negative 1.76. So T statistic, negative 1.7647, and the p-value is 0.0389. P-value is definitely less than alpha, which is 0.05. This is 0.3, this is roughly 0.4, but this is 0.5. So statistically significant, we will reject the null hypothesis. There is sufficient evidence coming from this sample to conclude that the mean commute time has decreased. So there is sufficient evidence, but it has decreased from 27.6 to 27.3. So it's statistically significant. But what about practical? Practical significance. If you reduce my commute time from 27.6 to 27.3 minutes, I will not be unhappy, but I will not be happy either. None. No practical significance. Yeah, it's statistically significant. The test showed that it has decreased. They timed better the traffic lights, but the reduction is it's not even a minute. It's few seconds, 20 seconds or so. So who cares? So no practical significance. Although statistically it's correct, it's statistically significant. We reject the null hypothesis. Indeed, they did a good job, but not good enough because that's not practically significant. Okay, one more example before we look at problems in Tet 3 in MyLabs Plus. Okay, in 2003, the average age of a mother at the time of her first childbirth was 25.2. So 25.2 years young. To determine if the average age has increased, can anyone give us the alternative? Anyone?
It wants us to determine if the mean age has increased.
Yes.
25.2.
So what is the symbol? I couldn't hear you.
Greater than.
Thank you. Thank you. Sorry, I couldn't hear. A random sample of 1,200 mothers is taken and is found to have a sample mean of 25.5 with a standard deviation of 4.8. Determine whether the mean age has increased at a significance level of 0.05. It's a large sample. It's independent, greater than 30, normally distributed, simple random sample, conditions are fulfilled. So I will determine the test statistic. And I should always show the picture. So we're talking about greater than. So this is our alpha, 0.05. So the test statistic again is x bar 25.5 minus 25.2 over 4.8 and the square root of 1200. And degrees of freedom, 1999. And then at this point, we will determine the p-value and draw conclusions. So, and after this one, I'm going back to show all of them with StatCrunch. Okay, so test, it's a t-test. We have stats. So mu0, 25.2. And 25.5 is x bar. And the standard deviation is 4.8. Sample size, 1,200. And this time is a right tail test. I want to draw. And it draws and gives us the p-value is 0.0153 and the test statistic, T statistic, 2.1651. So this is definitely lower than alpha. And we will reject the null hypothesis. Based on the sample, there is sufficient evidence to conclude to reject the null hypothesis and say that the mothers at their first child age has increased. But it has increased from 25.2 years to 25.5 years. Again, statistically significant, but practically, what's the difference? Just a few months. So there is no practical significance. Okay, so now let's go to StatCrunch. I'm going to share. I got a warning. Okay, fine. So I'm going to move you and go back to the main menu and StatCrunch. Open. Okay, so we go to Stat and we go to T Stats, and we're still working on one sample. Okay, and with data or with summary. So let's look at the first one with summary. And which one we want to start with the summary? Let me go back. Okay, so the first one with summary was with mu sample mean. Where's my keyboard? Got it. Okay. Sample mean, 70.78. Sample standard deviation, 2.77. Sample size, 43. Hypothesis testing, yes. And we were testing equal, and we were testing greater than, and the value was 69.5. Okay. We don't want a confidence interval. I want the p-value stored in a data table. I have to move you. Okay. And the value plot. Yep. Okay, let's see what happens. We know the answer. So go to the next. Okay. So here's the p-value. What did we get? Exactly the same thing, 0.021. And the p-value is here. The StatCrunch doesn't know what alpha we chose, but it doesn't matter. It's so small anyway. So we reject the null hypothesis. There is sufficient evidence to conclude such and such. Now let's look at the one with data. So I want to a new data table, and I'm going to enter 19, 19.68, 20.66, 19.56, 19.98, 26.5, 19.61, 20.55, 20.36, 21.02, 21.5, and 19.74. Do I have all 11? I think so. And I want a T1 sample with data. Variable 1, yes, I'm selecting it. Where optional hypothesis. So what was, okay, 20.1. What else I have? Store in the data table, why not? P-value plot, yes. Histogram with me, no. No. Color, I don't care. Rows, yep, that's fine. And let's compute. Okay, so let's see what we determined a few minutes ago. What was that? here it is. So exactly the same p-value, 0.3226. And the T statistic is 1.0406. Everything the same. Any questions?